Okay, so let us solve the next problem. So obtain the Maclaurin series of e power sin x. First we have to consider y of x equal to e power sin x. So if I substitute x equal to 0, I will have y of 0. So that is e power sin 0 is 0, e power 0 which is 1. Let us calculate y dash of x. So the differentiation of e power sin x is e power sin x into differentiation of sin x, that is cos x. So what is y dash of 0? So it is e power 0 which is 1, and it is cos x is what? It is cos 0 which is 1, so it is 1, right? So then we can say that e power sin x is y, so y dash is equal to, so y into cos x, right? So what is y double dash? So differentiate this with respect to x. So that is given by first function, differentiation of second function. What is that? It is minus sin x plus second function. What is the differentiation of first function? It is y dash. Now substitute x equal to 0. So y dash of 0, that is equal to, so y of 0 into minus sin 0 plus, okay, so plus cos 0 is 1. So cos 0 into y dash of 0, right? So here it is sin 0 is 0, 0 into anything is 0, plus cos 0 is 1. What is y dash of 0? Y dash of 0 is 1, so it is 1, right? So now let us calculate y triple dash. To calculate what is y dash, let me simplify that, is minus y into sin x plus cos x into y dash, right? So now we have to differentiate this with respect to x. So we will have y triple dash of x. So what is y triple dash? We have to apply the product rule here. The first function is minus y. So it is first function into differentiation of sin x is cos x, plus second function into differentiation of minus y is minus y dash, right? Plus again we have to differentiate with respect to x. We have to make use of the product rule. So first function and the differentiation of second function is y double dash, plus second function, the differentiation of first function is minus sin x, right? So it is minus y cos x, right? So we can take cos x and sin x common, right? So now we can substitute x equal to 0 here, right? If I substitute x equal to 0, I will have y triple dash of 0, cos 0 is 1, and y double dash of 0, y double dash of 0 is 1, minus y of 0, y of 0 is 1, okay? So minus 2 into y dash of 0, so y dash of 0 is also 1, and sin 0 is 0. I just substitute x equal to 0. So what happens here? It is 0. Yes, y triple dash of 0 is 0. Fine. Now let me consider this and let me differentiate this again with respect to x to calculate the fourth derivative of y. So the fourth derivative of y, so we have to apply the product rule here. The first function is cos x and the second function is y double dash minus y. So first function and the differentiation of second function is y triple dash minus y dash, right? Plus second function into differentiation of first function, that is minus sin x, right? So minus 2 into, so here we have to apply the product rule for y dash and sin x. So first function is y dash, second function is sin x. So first function, differentiation of second function, that is cos x, plus second function into differentiation of first function is sin x. The differentiation of y dash is y double dash. Now let us substitute x equal to 0. So the fourth derivative of y at 0, that is equal to cos 0 is 1, and y triple dash of 0, y triple dash of 0 is 0, minus y dash of 0, y dash of 0 is 1, plus y double dash of 0, y double dash of 0 is, y double dash of 0 is 1, minus y of 0, y of 0 is 1, so it is 0, minus 2 into, so y dash of 0, so y dash of 0 is 1, and cos 0 is 1, plus sin 0 is 0, right? So it is minus 1, this is 0, and this is what, minus 2 times 1, so which is 1 minus 2, which is minus 3. So right, so now we can find the Fourier Maclaurin series of y of x up to the term containing x power 4. So y of x is e power sin x, and y of 0, so y of 0 is 1 plus y dash of 0 is 1, so it is x, plus y double dash of 0 is also 1, so it is x square by 2 factorial is 2, plus y triple dash of 0 is 0, plus the fourth derivative is what? It is x power 4 by 24 into minus 3. So it is 1 plus x square by 2 minus x power 4 by 8. So this is a Maclaurin series of e power sin x up to the term containing x power 4.